Last lesson we looked at Pythagoras' theorem. Basically, what he said was that if you square two shorter side lengths of a right-angled triangle, they'll be equal to the side length of the hypotenuse. Remember, one of the cases we had was one where the two shorter side lengths were 3 and 4, and the hypotenuse was 5. Now remember, if we square this number here, and this number here, if I add that to that, it should be equal to that. Let's just check it out. So 3 squared is 9, plus 4 squared is 16, equals 5 squared is 25. And when I add 9 and 16, I get 25. 25 equals 25. So that's just proving how Pythagoras works, or showing you how Pythagoras works, remembering that it only works on right-angled triangles. The two examples, or the three examples rather, that we went through in class all involve the unknown side length as the hypotenuse. The obvious question now is, what if one of these smaller side lengths were actually the unknown values and we knew the hypotenuse? So of course that's the next and more logical application of Pythagoras. So the next lesson, and the lesson that we were due to cover today, and hopefully I am covering today, is calculating the shorter side lengths. So this is just a quick synopsis that Ms. Richardson has put together. Pythagoras knew that his right-angled triangle theorem could be manipulated. So we change his traditional formula, c squared equals a squared plus b squared, or we manipulate that formula so that the length of one of the shorter sides of a triangle can be found if the length of the other two sides are known. So basically we can manipulate it so we can find one of these shorter side lengths. So we go on to look at how that actually works, remembering that 7 is the same as 3 plus 4, but it can also be written as a difference. And basically what's happened to change this into this is that 4 has been subtracted from both sides. Now when I add and subtract 4, that cancels out, and 7 take away 4 equals 3, or 3 equals 7 take away 4. So if this is Pythagoras' theorem here, what we can do is actually say subtract b squared from this side and this side, okay, and that's that one there, okay, or we can subtract a squared from this side, okay, which is that one there. So basically what it allows us to do is manipulate his formula to suit us so that we can find one of the shorter side lengths. I've included this slide here in your notes. Basically it's a series of 8 different attempts at transposing or manipulating Pythagoras' theorem. Some of them work and some of them don't. So for example, I'll just give you a tip, that one works. Okay, well that is Pythagoras' theorem, so it obviously works. This one has had some attempted manipulation done to it, okay, and I'll just quickly show you how it's happened. We know that c squared equals a squared plus b squared. Okay, and what we've done in this case here is we're saying let's subtract b squared from both sides. Okay, now remember what that does is cancels out, okay, leaving us with a squared equals c squared, take away b squared. Now if we square root this side and square root this side, we get a equals the square root of c squared, take b squared. And that's what we've got, so that one works. Now some of them won't work, so I want you to go through later on and just tick the ones that are good, or put the word true next to the ones that are okay and false next to the ones that don't work. Alright, now into the examples. So there'll be 3 examples that we'll work through for this particular exercise, which is exercise 3b, and then I'll put that slide up at the end again for you, and that'll be the work that we do. So these 3 examples should just about cover you for most of the different ways the questions are asked. I've put these into a Word document just so that I've got a little bit more space to write them down. And because it's Pythag, I really do need to use my calculator to work these out. So I might just change the zoom on that. Small, just so that I can fit it on the page. And I'll just open up the LCD window so we can see it a little bit better. Okay, so this first example here, now remember we know that this side here, where's my review and ink? Okay, so remember we know that this side here is the hypotenuse. The way we know that is that if I draw an arrow there, the arrow points to the hypotenuse, or the hypotenuse is always opposite the right angle. Okay, I'll just change this to always on top as well. Okay, now so what we're going to do is just use Pythagoras' theorem as normal, so let's just write it out. C squared equals A squared plus B squared. Okay, and now let's fill in what we know. Well, this time it's a little bit different because what we do know is we know C squared this time. That's 17 squared equals. Alright, now because A is one of the variables that has been declared as the unknown here, what we'll do is we'll just say that that's A squared there. Okay, plus, now 15 is the other side length that we now know, which is 15 squared. Alright, so now basically what we'll do is we'll transpose this to make A the subject, and the way we do that is we subtract 15 squared from both sides. So I'll just write that in small writing here. We'll do subtract 15 squared and subtract 15 squared. Okay, now I'll do the flip all in one step. So I'll just change this to make or bring A on this side, and I'll rewrite it as 17 squared take 15 squared. Alright, remember we want to get A by itself, so we square root it, square root both sides, and that will leave us with A equals. Now I'll go to my calculator, and I'm in the main screen there, bring up my soft keyboard, square root sign, and I type in 17 squared take away 15 squared. Now I'm just checking, I think from memory they wanted the answer as a decimal. Let's just see how it comes out. Oh, it comes out as a nice integer value, so A is 8. Okay, so I'll just write that down. Alright, I check for units, no units there, so I can leave my answer as A equals 8. Now I just check that this makes sense in the context of the question. It is less than the hypotenuse. The hypotenuse is the longest side length, so I know that 8 is probably the right answer. Okay, let's move on to the next question. So, similar sort of approach here. We've been given the hypotenuse 10 and one of the shorter side lengths. So I'm guessing that this side length here might be 4 or 5. Let's see how we go. So, write in Pythagoras, C squared equals A squared plus B squared. Alright, now let's fill in what I know. I know that C squared is the longest side length, that's 10 squared, equals. Alright, now I've got an unknown of x, which really means that either A squared or B squared can be x. It doesn't really matter because it's addition. It doesn't really matter which one I use as the x value. So I'm going to sub in x for A. So I'm just going to say that A is x squared plus 7.6 squared. Similar approach to the last question, make x the subject or x squared the subject, and that will be 10 squared take away 7.6 squared, because remember what I'm doing is subtracting 7.6 squared and subtracting 7.6 squared. Alright, square root this side and square root this side leaves us with x equals. Alright, they want it to 2 decimal places, so let's do it. I've got 10 squared take away 7.6. Where's the square button there? Alright, so they're telling us the answer is 6.499. So basically what we'll do is we'll use the 9 to round that up to 1. Or push that 9 up to 0, then that to 5. So my answer will be 6.5. Again, there's no units in the question, so we don't need to write units in the answer. And it kind of makes sense. It's less than 10. I guessed 4 or 5. I was wrong. I can handle that. Okay, the last one. This is a tricky one, this one, and it's a really common sort of higher standard question from shorter side length. Okay, so basically we've been given the hypotenuse, and really for Pythagoras to work, what we need is we need another side length. Okay, and this is a little bit controversial because really they haven't given us a measurement of another side length. But what they have said to us is that that and that are the same side length. So if that's x, this side length here must also be x. Now the benefit of knowing this is that it still only is one unknown. Okay, and we can solve equations with only one unknown. So let's just run with Pythagoras' theorem and see how we go. C squared equals a squared plus b squared. Alright, let's fill in what we know. We know that c squared is 3 squared, the hypotenuse squared. And we know that these other two side lengths are in fact x squared plus x squared. Alright, now what we'll do is we need to be aware of the laws of adding indices here. We've got an x squared and an x squared. When I add an x squared plus an x squared, I've got 2x squared. Okay, now the tough part. What we need to do is get x by itself. Okay, so I want this to be x equals. That will tell me what these two side lengths are. So the way I'm going to do that is divide by 2 and divide by 2. Why? That cancels out, leaving x squared by itself. So I know that x squared rather equals 3 squared over 2. Okay, let's square root this side and square root this side. So I know that x is equal to the square root of 3 squared over 2. Now let's check. They're asking for the answer in exact form. So on my calculator I flick it into standard mode and I type in square root of 3 to the power of 2, 3 squared over 2, and enter. Okay, and they're telling me that the exact answer is x equals 3. That little dot there is a multiply sign, but we don't write that in, so that's 3 root 2 all over 2. Now, you might be thinking, what? I mean, how is that a side length? But remember, flick it into decimal mode and check out what it is, or check out what it is approximately. It's 2.12 approximately. And try this out, girls. If I take that value there and oops, let's grab it, stick it there, and what I'll do is I'll square that value and I get 4.5. So this side length here is approximately, when I square it, is approximately 4.5. This side length here, when I square it, is approximately 4.5 because it's the same. And when I square this side length here, 3, I get 9. Well, what's 4.5 plus 4.5? 9. Okay, so that it basically works. It really does. It just is an unusual way of seeing a length. If I told you that a length is 3 root 2 over 2, you'd think I'm crazy. But remember, that's the exact answer. All of these other things, the decimals, 2.12 would be an approximation. So girls, that basically is the explanation. So make sure you've annotated your notes with those that working out there. Okay, and then what you'll basically need to go on with now is the exercise. It's exercise 3B. Note the questions there, please, girls. Those of you who are really ploughing through this material, cut down on some of the fluency questions and go straight to the extension questions. So don't repeat the process if you're thinking, oh, I'm all over this. Go straight to these extension problems and make sure it's you do things that are a little bit tricky for you. Okay, so also there's the mathletics that I wanted to set. There's mathletics from last lesson and today. Okay, so I've set both of those exercises, and the sub teacher should have your passwords and usernames. So also spend a bit of time installing the app, or make sure the app is installed, and then go in using your password, and you should see the 2 exercises that I've set. Hopefully that's all clear, girls, and I'll be back Tuesday, Wednesday, whenever our next lesson is, and we can go through any problems. Also, don't forget to email me to let me know how you go. Alright.